Good afternoon, all. Welcome to interview preparation session. As yesterday, we have discussed regarding what is ML and what are the types in ML, and what is supervised, unsupervised learnings. And in algorithms, supervised and unsupervised algorithms, what are the difference? And what is reinforcement learning and supervised learning and regression techniques and all, right? And where we use, why we use regression models, and what is linear regression, what is logistic regression, and what are the differences of linear regression and logistic regression, and why we use those regression techniques and all, right? And for linear regression, which type of output do you get? Just give me your quick answer. Yes, in linear regression, we get continuous output, right? And in logistic regression, we get discrete output. And next, we have gone through what is polynomial regression and where we use it, and SVR. Just I have given you brief introduction regarding decision tree. What is decision tree? What is decision tree? What is decision tree algorithm? I'm waiting for your answers. Once I'll move further. Yeah. Decision tree algorithm, where we use, that is my question. In decision tree algorithm.
But Grammarly can help. This sentence is grammatically correct, but it's wordy and hard to read. It undermines the writer's message and the word choice is bland.
Welcome back. Let us see how to create a simple matrix in Power BI. First of all, why do we?
Yeah. And we also gone through the random forest. Yes, decision tree contains nodes and leaves. So it is the algorithm where our data set is divided into sub data sets, and again you will get, again you have to derive some algorithms in order to get the output predictions. So here, what the action you do? What the action you do, guys? Here you have to take the nodes and place. Okay. Next you have, if you see the ML algorithms, where do you use the classification models? Where do you use the classification models? Yesterday we discussed, right? Where do you use the classification models in order to make some decision regarding yes or no, and also if the patient is having some cancer or not, or if the patient is having some disease or not, or regarding the color, is the color is black or red, like that. In order to get the binary description, we can use the classification models, right? So in it, we have gone through simple linear regression, and logistic regression, and polynomial regression, and SVR, along with it, decision tree and all, right? Now, random forest. What is random forest? What is random forest? Random forest, it is containing some yes ensemble models. Yes, it is the combination of ensemble models where in order to predict the outputs of your business problem, right? So here, let's start regarding ensemble models and all, right? So today, let us start our session continuation to what do you mean by what are ensemble learning techniques, right? Anyone, please? What are ensemble learning techniques? Yes, Banu, it is bagging. Yes. Bagging, boosting, stacking. Yes, very good, Banu. So ensemble learning techniques means here what you have bagging, boosting, and stacking, right? So here, what do you mean by what do you mean by ensemble learning? If you give the in a sentence form, if you try to say, so how can you do the process? Yes, random forest, ADA boost, gradient boost, XZ-boost, and all. Very good, Banu. Yeah. So here, the first thing in ensemble techniques, if you see, The next question for you is, what is stacking? What is stacking? What is stacking, guys? Parallel. So stacking is an ensemble learning technique which uses predictions from the multiple models. So whenever you consider the ensemble techniques, there you have to use multiple models, right? So while using multiple models, like multiple models means what? For example, can you give example for multiple models? Next, my next question is, give examples for multiple models. Just you have to give some examples for multiple models. What do you mean by multiple models? Decision tree, KNN, or SVM, or any type of algorithm you consider, those consider multiple models. So stacking means what? Stacking is an ensemble learning technique which uses the predictions from multiple models to build a new model. Yeah, logistic regression, KNN. Yes, Banu Prakash, very good. Yeah. Can you say what is boosting? My next question is bagging is right. So what is boosting? Anyone? What is boosting? I'm not getting any reply from you. There are 6 members. Yes, it is also a combination of homogeneous models, but it works sequentially. So boosting means it is an ensemble learning method that combines set of weak learners into a strong learners to minimize the training errors. So whenever you take training errors, there a set of weak learners into strong learners to minimize the training errors, we use boosting. And the training errors, how the training will go? Sequentially the training be performed. So how can you classify that? How can you define that boosting? No one giving answer except Banu Prakash. Okay, no problem. So you can define boosting technique as boosting technique is an ensemble modeling technique that builds a strong model. Which type of strong classifier you can say, right? So boosting technique that builds a strong classifier from number of weak classifiers, right? That builds a strong classifier from multi-weak classifiers. Okay, how and the process is, and how it consider that the process will be in a sequential way, right? That's why it is called a boosting technique, because it builds a strong classifier from weak classifiers. Clear? Yeah. Now, in it, my next question is, what is ADA boosting? What is ADA boosting technique? Right. What is ADA boosting technique? Okay. So ADA boosting means here you have ADA boost classifier. That means what ADA boost classifier is a classifier which actually works on fitting a classifier on the original data set. Okay, this is a classifier which works for the fitting a to fit the classifier on the original data. Okay. And another question: what is which type of algorithm plays an important role in ADA boosting? Which algorithm plays important role in ADA boosting? Next question for you. Please. No, I'm asking in the process of ADA boosting, which classification plays an important role? Which classification plays an important role? Yeah, very good, Vicky. Decision tree. Bhanu Prakash, very good. It is decision tree. Yes, it is. This is a decision tree, right? So, Now, next question for you is, what is gradient boosting? What is gradient boosting? Yes. Here, gradient, of course, you know that. Meanwhile, I'll explain what is gradient boosting. Just I'm waiting for your answers. Yeah, here, gradient boosting algorithm is very important algorithm in the field of machine learning, right? So it is used to predict not only for the regression models, but also for the classification models also. As I said previously, regression model. For regression model, what will be the output? What is the output for the regression model? Anyone? What is the output for the regression model? You can use regression model as well as classification models also. So gradient boosting algorithm is a very important algorithm, very powerful algorithm also in the field of machine learning. Why? Because this type of ensemble technique be used in order to predict the output variable, not only the regression purpose and but also means classification purpose also. Yeah, what is the regression output? If the yes, it is the for regressor. What is the output target? Output target be in the continuous form, means variable form, and in the classification, what is the output? Categorical form we will get, isn't it? So in the both fields, you can use in both algorithms, you can use the gradient boosting. That's why it is very important algorithm. And it is also very successful algorithm. And here also, which one is the important algorithm in order to do the predictions by using this particular type of uh, ensemble technique? Maximum we use here also, we use the decision tree only, right? Yeah. Next, you yes, categorical also. Shalini, very good. My next question is, what is XG boosting? What is XG boosting? XG boosting means what? First, me what is meant by XG. What do you mean by XG? What do you mean by XG? Extreme gradient boosting. What is that? Extreme gradient boosting algorithm, right? So XG boosting, first thing is XG boosting stands for extreme gradient boosting. Here in this algorithm, we use accurate approximations in order to find the best model. Extension of gradient boosting. Yes, Panu, good. Extra gradient boosting. Yes, Teju, yes. Vicky, extreme gradient. Shalini, yes, it is extreme gradient. And it is also very important, easy to apply, and it is having its special weightage. Why it is better in comparing to the previous boostings? Of course, in the previous boostings also we are using decision tree only, right? But it is having some important. Why it is having important means, my question is like, how can I ask? Importance of XGBoost, right? Importance of XG boosting. Why we use XG boosting is having so much important? Why so? Do you know the reason? In the machine learning algorithms, we are having some ensemble techniques, and in those ensemble techniques, we are just giving brief description regarding what are the types of ensemble techniques, and we are discussing what is that all those type boosting, stacking, and all. In that, I am asking, we came to XG boosting. Now I am asking, it is having some important place. Why it is XG boosting is occupying some important place? What is that? I'm asking. Yes, Panu Prakash, performance and speed. Performance and speed. Okay. More than that, another 2 points are there. Of course, it is XG boosting is having its in its implementation, it is giving accurate predictions and also which are scalable, right? So because of the scalable and accurate implementations of the predictions, it is having its own weightage. Okay, and as you said, it is also easy to run and it is fast. Okay. Yes, Nishanti. Yes, it was built and developed for the purpose of model performance and computational speed. Okay. So here, as you said, here we know what is random forest, and bagging we know, and boosting we know. Now my question is, if you see, my next question is like, always in all algorithms, what we are using, which type of algorithm we are using? We are using decision tree, right? So in that decision tree, if you see, okay, like Random forest. Do you know the random forest technique? Is it a bagging or boosting technique? Random forest or is random forest? Bagging technique or boosting? Yes, because all here all we are using decision trees only. Yeah, is it bagging technique or boosting technique? Yes, Bhanu Prakash, it is bagging technique. So random forest comes under the bagging technique. Okay. Okay. One question. One another very important question, that is, what is the difference between bagging and boosting? Here we are saying that we are discussing regarding bagging and boosting, right? Now my question is, what is the difference between bagging and boosting? Ensemble techniques. Trinity, extension of bagging. I see. Questions. Here you can note down. I can scroll up and down, right? You can note down the questions, right, Vicky? If you want, I can, but I don't know in which WhatsApp group to share, right? So my question is, what is the difference between bagging and boosting? Okay, Bhanu, bagging computes parallelly, boosting computes sequentially. I see. Here computes means what? What do you mean by computes? Actually, bagging means what? Boosting means what? As I said previously, depending on the weak classification, boosting gives us the strong building, right? Boosting builds a strong classification. Okay, so for that, what is happening? The same in case of boosting, number of iterations are adjusting on the previous classifications. Yes or no? In case of boosting, what we are doing? In case of boosting, number of iterations we are performing on the previous classifications only in order to build a very strong model. I mean classification, right? That is boosting. Okay. In case of bagging, what technique we are, what is the main motto for us? In case of bagging, what is the main motto for us? In case of bagging, my question is, in case of bagging, what is my choose the variance of the predictions? So for that purpose, what we are doing in case of bagging, we are considering. Yeah, Bhanu, very good. Here we are considering training from the data set, and we are combining the repetitions. Okay, again we do some combinations, again we create multi sets. Okay, again we do some bagging. So we are creating number of bags. Okay, so the main difference is, in case of boosting, what we are doing, we are going to build a strong model depending on the using only previous classifications only. We are okay. And in case of bagging, the main purpose is to reduce the prediction variance. You have to remember these points. In case of bagging, what we do, we reduce the variance of our predictions. How we can able to reduce the variance of predictions? By taking some additional data to for training from the data set, and again we combine it, again we create another data set. You can say multiple data sets we are going to create from the our original data, and we do continuously. Then what happens, whatever the variations are existing in our output predictions, that will be reduced. Okay, that is called the bagging. So this is the main, solve over the fitting problem. Okay. Now, as you are saying, fitting problems and all, okay, let us ask you one question, that is, let us ask you one question, that is, in case of yesterday we have gone through, I think you have idea regarding the linear regression, right? Then in case of linear regression, in linear regression, what type of errors do you face? In linear regression, okay, as you are saying some overfitting problem and some problems you are saying. Okay, my question is now, in linear regression, what type of errors do you get? Very simple question. Yeah. In linear regression, we get what type of, in order to get the error, in order to solve the error, what type of metric, you can say, what type of metric do you use? How can you, you can say, how can you calculate the error? in case of linear regression, how can you able to calculate the error? Not what type of error? In linear regression, how? Yeah, instead of what? How can you calculate error? Yes, calculate errors. Yes. Okay. In linear regression, okay, errors you will find. What do you mean by errors? First thing, what do you mean by error? That is the difference between the MSE or MSE. Very good, Shalini. Error means what? To the original one, to the original output, to the predicted output, some variation will exist. The difference will exist. Okay, that difference is called as the error. Okay, in linear regression, what happens to the predicted value and to the output original value? There exists some difference. The difference between the predicted to the original values is called the errors. Okay, is called error. So how can you able to predict, how can you able to calculate that error in case of linear regression? By using mean square error, MSE, by using MSE. So by calculating the MSE means what? Mean square error. By calculating the mean square error, okay, that means what? How can you calculate? That is the distance between the observed output value from the predicted output value. Okay, if you have a graph, suppose think if you have a graph, if you have there for on x-axis you have x1, x2, x3 like that, and on y-axis you have the outputs. Suppose at each x value you might have y values, right? So the original one and the predicted one may have the distance between these 2 points at each value of x variables, x1, x2, x3, that gives you the error value. So there you have to take the mean square, MSE, that gives you the calculation of the error. Okay, so here how can you calculate the errors in linear regression? You can calculate the linear regression in MSE, mean square error. Yes. Yes, I asked previously, what is the major problem you face in case of linear regression? My next question is, yes, what are the major problems in linear regression? What are the major issues you face in case of linear regression? Yeah, Sham. It is mixture of different models. Shalini, difference between actual value, predicted value. Yes, it is. Nishanti, false negative error, false positive error. I see. Mean square error. Now, here my question is, what are the major problems you face in case of linear regression? There are at least two I want, at least two. Here, non-linearity, right? The first one, the first major problem in case of linear regression is non-linearity, isn't it? So non-linearity means where you will get the non-linearity? Where do you get the non-linearity? I am not getting any response from your side. Why so? Okay. Here, this non-linearity means you can say relationship between the response values to the predictor values. Okay. Response values to the predicting values. Non-linearity. And next point comes, if I'm not wrong, next point is correlation. Okay, correlation of terms, error terms you may say. Okay, non-linearity, correlation of error terms. Okay, and also another thing is constant, non-constant variance. Okay, any error term, if you say, if you consider, if any error term, if you take a non-constant variance will exist. Okay, these things you may consider. No, not in logistic regression, Bhanu Prakash. In linear regression, I am asking what are the in linear regression, what are the major problems of you face? That I am asking. For that, I am saying non-linearity, correlations of error terms, and also non-constant variance of the error term. You may add more. Okay. Okay, in case of linear regression, you have to assumptions you have to do, right? Some assumptions you have to do in case of linear regression, right? What are those assumptions? My next question is, what are the assumptions you consider in linear regression? What are the assumptions you consider in case of linear regression? First thing you say, do you consider, do you do some assumptions or not? Yes or no? If you say yes, what are those? If you say no, why no? How many assumptions you do? First thing, 4 assumptions we have to do in case of linear regression. Okay. In any regression model, you have to do the 4 assumption. First one is the linearity. What is that linearity? What is that? Linearity means what? In any regression model, you have to do the linearity, right? You have to see the linearity. Linearity means Linearity means what? The relationship between X and Y. Okay. Right? So the first point is the linearity, the relation between X and the Y. And second one is homoscedasticity. What is that? Homoscedasticity. What do you mean by homoscedasticity? Anyone, please? It is nothing but the variance of the residual should be same for any value of X. X is the input, right? Independent variable. Okay, Y is the dependent variable, as I explained yesterday. So the variance of any residual means you can say error. Okay, the variance of the residual should be same for any value of the independent value, that is nothing but X. For any value of X, the variance of the residual should be the same. That is called the homoscedasticity. Got? Next, independence. What do you mean by independence? The observations. What are the observations you do? Those observations should be independent of each other. Whatever the observations you do, the observation should be independent from independent of each other. Okay. Yeah. Okay, fine. Here, as we are saying, it is very easy and apply to for predictions and all. What is the disadvantage of linear regression? What is the next question is, what is the disadvantage of linear regression? What is the disadvantage of linear regression? Give me your quick responses. Here, in the linear regression, we are assuming what we are assuming linearity between the independent variables and the mean of the dependent variables, right? So here in linear regression only gives focus on the mean value of the dependent variables. Okay, linear regression focus on the mean of the dependent variables only, and it looks only the relationship between the dependent and the independent variables. It is the main disadvantage. Okay, and it is very sensitive to outliers. Okay, here we got outliers, right? So my next question should be, what is outlier? Okay, anyone? So what is the disadvantage of linear regression? In that I said, in linear regression only we focus on the mean of the dependent variables and the relationship between the dependent and independent variables. Okay, and these are very sensitive to, linear regression is very sensitive to outliers, right? And another thing, data must be independent. Yes. Yeah. Okay. Now my Next simple question is, what is outlier? Extreme value. Yes, Banu Prakash, extreme value means? Extreme value, what do you mean? For what? Yes, guys, I am waiting. What is outlier? Simple question it is. Yeah. Yes, Banu. It is other values different from other values in the data set. Very good. Yes, it is. Outliers means in any data set, if you consider we have some observations, right? If you have observations like 1, 2, 3, 4, 2, 3, and at a sudden, all of a sudden, if you got any outlier like 50, okay, you have some 10 observations. In those 10 observations, you have the values like 1, 2, 3, 4, 5, 3, 2, 1, 4, 5. All of a sudden, at the middle or in those 10 observations, all of a sudden you got some 50. Okay, that 50 value become outlier. Why? Because if you consider observations, the value, any value which is having very large magnitude compared to other observations, okay, which is also called the residual. Okay, if you are having some observations, in that observations you are facing some one large value. How can you say that is large value? By comparing the magnitudes of other observations. Okay, that is called the outlier. That is called outlier. So outlier is the which is not similar with the other observations of your original data set. It will affect your accuracy of your model. Okay, whenever you build any model for your client, then what happens? It will affect the accuracy of the your model building, right? That's why you should be very aware of these outliers, right? And also it is very important to detect the presence of outliers, right? That's why we can say in case of linear regression, it is very sensitive to outliers. So guys, what we have discussed today, we have gone through some types of ensemble learning models. Okay, yesterday we have discussed still random forest, right? From today, we have gone through ensemble learning models, and in that what is stacking and what do you mean by in that we got some multiple models, right? So in it, what multiple models means what? And boosting, what is ADA boosting, and what is the important role of ADA boosting? Next we have gradient boosting, what is that? And XG boosting, what do you mean by XG? Extreme gradient boosting, right? And what is the important, why it is very important? Okay, very famous it is in machine learning algorithms, right? After that, we gone through random forest. Is it a bagging or boosting? And what is the main difference between the bagging and boosting? Okay. After that, someone of you said some regarding some errors. So I wanted to discuss regarding errors also. So what do you mean by error? Why we face errors? What are the major problems regarding the linear regression, and what are the assumptions, as we are already discussing about the linear regression. Let us get the knowledge regarding linear regression, more knowledge regarding the linear regression. So I asked you about the assumptions what you made while building any linear regression algorithm, okay, while developing any model, okay. And also you have some disadvantages using the linear regression. What are those? Yeah, it is also very sensitive to outliers. So there we got outliers term. What do you mean by outliers? Okay, that way. Tomorrow onwards, I'll continue why we are getting outliers, and how can, what are the why we are getting, how can you able to detect those outliers, and how can you drop those outliers and all, and bagging and these ensemble techniques, and model building, metrics. That is very important. Okay, metrics of model building and machine learning algorithm. Regarding those points, tomorrow I want to cover. Right. Thank you for attending the session. Thank you so much. Have a nice evening. Bye bye.